Alright, so now I want to go and do some other modeling of functions. So here's one. This function's common domain, where it's both continuous and differentiables, all reals but 0. So again, we're going to start by finding the critical values of the function. The critical values of the function are where its derivative is 0 or does not exist. So, oops, I forgot that. Okay. So this will be 3x to the 6th minus 3 over x to the 4th. Why? Because for this to have a common denominator, I need to multiply this numerator and this denominator by x to the 4th over itself, and I said that backwards. Again, y prime does not exist at x equals 0, but that is not a critical point. Why? Because it's not in the domain of the function. dy dx is 0. How? If the numerator, which I can write this way, is 0, and by inspection you should see it's this. Okay. Now, so these are my critical points. Okay, let's take care of that sentence now. The critical points of y equals x cubed plus x to the minus 3rd, or x equals plus or minus 1. If they ask you to justify it, you do it this way. Why? Because y prime of positive or negative 1 is 0. Done. Okay, now let's analyze this and do, well, they want the local extrema. Okay. So it doesn't exist at 0, so I'm going to put a DNE, but remember, that's not a critical value. Negative 1, positive 1. Okay. 5. Okay, so this would be positive. This would be positive. A big positive minus 3 is positive. The quotient of positives is positive. How about 1/2? Okay, this would be positive. But this numerator is going to be negative, and therefore the quotient is negative. Okay. Okay. All right, now let's put like minus 3. Positive, again, a ratio of positives. And you should see why, because if you think about it, this is odd as a function, therefore its derivative is even. And you can prove that very, very quickly. Now, increasing, decreasing, local max. Decreasing, increasing, local, and that makes sense because that's an odd function. Okay, y of negative 1 is a local maximum by the first derivative test. Why? Because y prime of negative 1 is 0, and y prime dy dx changes signs from positive to negative about x equals minus 1. Now, I'm not going to write the last sentence, but I'm going to walk you through it. I'm just going to use this and just change a couple things. Y of 1 is a local minimum by the first derivative test because y prime of 1 is 0, and the derivative dy dx changes signs from negative to positive about x equals positive 1, period. Notice the sentence is almost identical, just some key words are changed.